We start as per our instruction plan. We are going to have our quiz 1 in next week. So next week we are going to have quiz 1, and so I have emphasized a lot, and I would emphasize one more time that please always, because we are having a full session with you guys today. But whenever you don't have a session, as we did not have last 2 weeks, so I shared the recordings with you. So please keep an eye on that. Always look at the recording, because in quiz you will be asked questions from that particular session, and you have to basically reply on the basis of that one. I cannot emphasize more on that one, that I have mentioned that whenever you have whenever you see that the answers, I would be looking for answers with respect to what we have discussed in the class, rather than a general answer. So please keep in mind that you will have to, maybe at times you will get a question that you would like to answer as per how it has been discussed in the class, rather than it is written in somewhere on the website, or maybe it's there in chat GPT or somewhere. So I would be looking for more answers from your own side. And as I said, you might have written down a perfect answer for something, but that perfect answer might not match the concept that we have discussed. So it won't be considered as the good answer or right answer, by the way, just for that matter. So again, for this section 8 students, everyone who is here, or those who are maybe will be looking at recording later on, keep in mind that in the quiz, in the final exam, in the midterm exam, you will be asked from what we are discussing in the sessions. It won't be much more, like, as I said, you might find it somewhere on the internet or somewhere, but that might be a perfect answer. But that, if that not does not reflect how we have discussed something in the session, it might not reward you. It might not be considered as an appropriate answer. So just keep in mind that whenever you get a question. Anyhow, let's just start our week 4. This is our week 4, and I do really hope that now you have, that again, this week we are going to have a session with you, and then next week it's just, or like every third week you will have a live session that we will have. Otherwise, you will be sharing recording. So next week, for your session, because we are not going to have a full session with you. So quiz will open up at 1 p.m. I'll just put that as an announcement. 1 p.m. it will open up, and it will be closed at around 5. Like, again, it will be open for the class session time, and you have to attempt that. If you miss that out, so that means, of course, if you do not attempt it during the time, of course, you will miss that quiz. And if you miss the quiz, there will be no retaking of the quiz. Just keep in mind, there will be no retaking of the quiz. So if you once miss because of any reason, if it is missed, it is missed. So even though, as I said, because we won't have the live session with you at from 1 to 2 next week, 1 to 5, but you will have the quiz opening at that time, so that you can just attempt your quiz. That is our class session, so that's why it would be during the class session, so that you can attempt that question over there, right? So keep that in mind. And next week we are going to have our quiz 1. And again, one last time, that we will be discussing mostly from what we have done, which we have discussed in the classes. And if I just start with a little survey, Varun, good afternoon. Little survey, that how many of you were able to look at the recording of last week's session and the previous to that, like again week 2 and 3, because 2 and 3 were done with other sessions, and I just shared the recording. How many of you were able to look the recording? And again, if you are the one who has not seen the recording as yet, I would really want you to just look at that one. And as I said, just take some notes, which might not be in the slides, which might not be in the slides or somewhere, but again, in the code as well. I've shared the class code as well, if you guys remember. So you can always run that. Okay, so this week is very interesting, and there will be a little bit repetition of the last week, because we are sharing 2 files, and I'll show you that one file from the server, which is already there, one file that I I always share after we are done. So yes, let's start with this week's session. So agenda ER diagrams, review and practice. We have discussed ER diagrams in last week. I was asking for this question. How many of you were able to look at the recording of last week, week 3? Because there are a few things that are repeating this week, and I would like to know that who was there who had a chance to look at the recording before that one. Can I have a feedback from everyone? Yes, Samprith, good afternoon. Samprith, were you able to look at the recording of last week? Hitesh, yes, you have done that. Wonderful. So Hitesh has done that. Anyone else? Okay, Samprith has had a look at that. Wonderful, Samprith. That's wonderful to know. And I don't know if about the others, why they are silent. If you have not done so, you can just write not, or maybe, half of them or whatever, but always respond. Varun, thank you very much. Varun has also responded that Varun was able to look at the recording. So wonderful. So Prabjot has done that. Wonderful. So you can just mention that. Vaishali, this is good. So today we are, as I said, there'll be some repetition. Ritu, thank you. So there will be some repetition over here. We'll talk about ER diagrams. We'll talk about properties of relations. Some of the properties we talked about yesterday, like last week. But today we'll just talk about some of them. Properties of candidate keys. We'll see some of the candidate keys and their properties, how to use them. Entity and relational integrity constraint. This is very important. We'll talk about some of the constraints related to entities. Good afternoon, Tarun. So, and then transformation of entity relationship and enhanced entity relationship diagrams to relations. We'll talk about how to convert them into relations. Define first, second, and third norm. This is something, as I said, last time we have discussed that one. So it is just a repeat for today, like from the last week. And again, repeat from the last week. This is, so I'm just mentioning this because I have not shared this file. I'll share later on. And normalization also is also the same. A repetition, right? It's repeat. So again, we won't be wasting too much time in that, but we will see that what are those in a little sense if you were not able to look at them before. So yes, so let's start with this one. Relation. What is a relation? Definition. A relation is a named two-dimensional table of data. So if you remember last week also, those who have looked at the recording, I told you that a relation is a table in database is basically also called as a relation. A database table is called a relation. Table consists of rows, the records, and the columns, the attributes or fields. And again, this is something that we have talked about little over here and there. Requirement for a table to qualify as a relation. That's a very important point. It's in a different way. When we are table, we say that a table is qualified as a relation, not in all circumstances, but there will be certain circumstances where we'll say that the relation is basically treated as a table. It must have a unique name. Table's name should be unique. First of all, if it is to be called as relation, every attribute value must be atomic, not multi-valued, not composite. This is very important. And we have talked about atomic and multi-valued value, last week. So every attribute value must be atomic or not multi-valued, just single value, and it cannot be further divided. Every row must be unique. Can't have two rows with exactly the same values for all fields. Remember primary key or any key that separates the record from the other records. This is another very important point, that every row must be a unique one. Attributes, columns in the table must have unique names. Every column should be unique. No repeating columns. The order of the column must be irrelevant. So again, if I put this column here or there or any place, that should not really matter, right? So it is, the column is basically irrelevant, that we have put that over here. The order of the rows must be irrelevant, and again, in the same way, the order of the rows is irrelevant. You can just do that. Now, the important point, the red point is here. All relations are in first norm. And again, mostly all these features, if some table follows these features, it's actually a table, number one. Number two, it is, because of these properties, it will be called as relation. And all relations are in first normal form. So again, a point to remember that all relationships or relations are in first normal form. Like again, if a table is to be called as a relation, it has to have these features. And also after having these features, it would be qualified as a relation. And if it is a relation, relations are in first normal form. Their all relations will be in first normal form. Now let's come back over here. Degree and cardinality of a relation. Degree is the number of columns. How many columns are there in a relation? Cardinality is number of rows. So degree columns and cardinality rows. This is very important. So we have talked about degree and cardinality. Now correspondence with the ER model. So how they fit in the ER model, entity relationship model? Relation tables correspond with entity types. Remember, this is very important, and I want you to just keep that in mind. These few things in mind, that relations basically correspond to the entity types. Rows correspond with entity instances. We have talked about rows are instance of an entity, and the table correspond with the entity type. It's a complete entity type, and then rows will be of particular instances, entity instances. And not to mention that columns basically they correspond with the attributes. So let's go the reverse way. The columns are attributes and the rows are entity instances, and the table by itself is called entity type. Make sense, everyone? This is basically what over there. Key fields. So what are the key fields over here? So keys are a special field that serve two main purposes. Now, there are two types of keys or two purposes. Primary key are unique identifiers of the relation in question. Examples include employee number, social security number. This is how we can guarantee that all rows are unique. If you are asked that how can we make possible that a table is a relation, so one answer might be to introduce a primary key in that relation. Make sense, everyone? Because the primary key will make sure that this will guarantee that all columns are unique. We might have first and last name common for two students, two persons. And who knows, we can have age common as well. We can have maybe city common as well. Let's talk about those major or macro level things. But the one thing that would differentiate between those two students will be primary key. So primary keys play a very, very important role. And the role is that they would allow us to recognize a record in a relation as as an individual or as a distinct record from the others. Right? Foreign keys. Now, foreign keys are what? Are identifiers that enable a dependent relation on the many side of a relationship to refer to its parent relation on the one side. So, relationship we have talked about last time, we have talked about one-to-many relationships. So foreign key, if it is mentioned, it's identified that enabled a dependent relation. A dependent relation on the many side. On the many side, they are called dependent relation to refer to its parent relation. And it will be referring to its parent relation on the side on the one side of the relationship. So in other words, there is a hidden line over here. That wherever there will be one-to-many relationship, the foreign keys will be involved. Right? One-to-many relationships, the foreign keys will be, and this makes a perfect sense as well, because a foreign key is typically that goes from one table to the other, and the second table we recognize the records for this first table elements by looking at the foreign key. Right? Now let's come back. Keys can be simple, a single field, or composite, more than one field. That is an interesting part. Like, keys can be one field, but in certain situations, one field might not be enough because, maybe for some reasons there are keys repeating or something. So then we will composite or combine two fields together and make them, make them a key. Just remember that one. Now here, if you look at that one, so for the customer table, if you look at that, customer ID is something that we can say that, okay, ID of the customer, and that is a primary key for that table. So look at that. Again, I say customer name, and it's very much less likely that address will be same. But let's talk about an imaginary world. Person's name is same, address is same, city is same, state is same, postal code is same. Let's talk about that. In a very vague situation. Even if that happens, customer ID should be the one that will differentiate between these, and that is called primary key for that one. But when they will post an order, they will keep an order. So order table will have order ID, date. So this is related to order, and this will be called as a foreign key. Because one customer can make many orders. So whenever, look at that, foreign key implements one to n relationships, like, one to many between customer and order. So if a customer makes 5 orders, so again, 1 to 5, whatever. So a customer can make multiple orders. So that's why we take the ID of the customer and we place it in this table, so that when in table record comes, I know that which customer has given that. Right? Makes sense? Now, order line. Now this is interesting. Order line. So order line is basically, where this is called order line, where there will be an order going on. So order ID plus product ID, both should be combined to have a key. So that would be called as combined. These are composite primary key, uniquely identifies the order line. So order ID plus product ID. Who has given, what is the order ID and what is the product that they have ordered? So there might be multiple records. So multiple customers can have multiple records. So what it makes, uniquely identifies the order line, individually their foreign keys, implement M:(N) relationship. Like again, many to many relationships between order and the products. Make sense? Many customers can make many orders. So if a customer makes an order, so the order ID is reached here and the product ID, which product customer has mentioned, and combining these two, we will say that this makes it one column. Like, one column, not one column, like combine these two columns will uniquely identify. It will uniquely identify a particular record, right? So look at that. Combined, there are composite keys. These are composite key. Uniquely identifies the order line. Individually, they are foreign keys. Implement M:(N) relationship between order and product. Makes sense, everyone? Now, product. So product has a product ID, description, finish, standard price, product line. This is good. This is fine. But again, you are basically just representing that, product ID will be mentioned over here with the order, and we'll recognize that one. Okay, here come integrity constraints. Some of the integrity constraints. That is very interesting. Last time we saw some of the constraints, and now today we are looking at some of the constraints. Domain constraints, allowable values for an attribute. This might not be the case that you can write or you can give any values to attributes. At times, you might have situation where you will be just allowed to use or allowed to give particular elements, particular values for particular attributes. Make sense, everyone? You will be allowed to have multiple. So that is called domain constraints. Domain constraints. So again, what are the values that I can put for attributes? Then entity integrity. No primary key attribute may be null. All primary key fields must have data. And that's another very, very interesting point. That entity integrity is what? No primary key attribute may be null. Remember one point. Never ever we try to make our primary key as null. This should never be a practice, that primary key is null. It is not, even though it might work, but it is not allowed, because if you make primary key null, it means that, you might not be able to just identify uniquely that record. And what can be other problems that if we do not have primary key null, what can be the other problems? Like if we have a primary key null, what can be the problems? Anyone?
If like it can repeat the value if we do not enter a primary key value, that will be null, and so there are repetition of the values which is not allowed in for a primary key.
That's wonderful, Sampri. That's wonderful. So it might repeat the values because there was like the records will not be uniquely identified. Then comes referential integrity, and we'll talk about this. Is very interesting. Referential integrity. Whenever the reference is used and the foreign key is used, we use this referential integrity to find out that. Now, domain definitions of invoice attributes. Now look at that. What can be domain definition? Enforce domain integrity constraints. Customer ID. So domain name customer IDs, set of all possible customer IDs, character size 5. Customer name is all possible names. Address is all possible addresses. Postal code, all possible addresses. So these are all possible values. And again, some of them have the limitations of it should be integer, of multiple, like how many digits should be there and things like that. So now let's go back. These are just a table for given for that one. Integrity constraint. Referential integrity. Rule state that any foreign key value on the relation of the dependent side must match a primary key value in the relation of the parent side. Very simple if you just remember. If, and this really makes more sense if I just show you this one. I show you the previous, this one. Look at that. Look at that, the first referential integrity. I'm again reading that and I'll show you the example. Referential integrity rule state that any foreign key value on the relation of the dependent side must match a primary key value in the relationship of the parent side or the foreign key to foreign key, or the foreign key can be null. Now listen that one. So it is the foreign key over here. Make sense? Now answer me. Is that possible that order is generated without a customer ID? Like there is no customer ID in the customer table, but I get an order. It's not possible. Are you guys getting that one? That a primary key, if it does not exist in the parent table, there is no use of that, or there is no record being created in that table where the foreign key has been mentioned from the primary. Does that make sense? So it's actually doing what? Referential integrity rule that state that any foreign key value on the relation of the dependent side must match a primary. It has to match. So any value over here, the customer ID has to match one customer ID. If it is not matching, so it can be possible, like without having customer ID, I cannot have record, like I cannot have order. Does that make sense? We cannot have order without. Now, must match a primary side on the front. Now here comes very interesting one. Delete rules. How to delete a record from that one? Restrict. Don't allow delete of parent side if related rows exist in dependent side. Now, if there is a record over here with a customer ID 1, 2, 3, 4. First point, very important, and try to remember that. Restrict rules. What is the restrict rules? Don't allow delete of parent side if related rows exist in the dependent side. So if there is some record in the order, never allow to delete this customer ID from that one. Can I have a thumbs up from everyone here? Are you guys getting that one? So you are not allowed to delete customer ID, any customer ID from this table. Why? Because I have got some dependent table where that record is being existing. So I cannot delete that. So this is called restrict. Now cascade. Cascade is automatically delete dependent side rows that correspond with the parent side row to be deleted. Now, what if I want to delete from this table, I want to delete this customer ID, cascade will refer that if customer ID is deleted from here, it should be deleted from the dependent table as well. That is, in our real life, we will say cascading something. So cascade, if I'm removing this from the parent side, remove it from the child side as well. Right? So this is the one. So Cascade automatically delete dependent side rows that correspond with the parent side to be deleted. So if I delete this one, automatically this customer ID should be deleted from the order. You know, for whatever reason, you will see there are some real practical reasons where you will be doing that one. You know, there will be some practical reasons where we'll be just doing that one. It's not like that we will be having, that same situation. So it is called cascade. Now set to null. Set the foreign key in the dependent side to null if deleting from the parent side not allowed for weak entities. We'll talk about what are weak entities. Now see, it's set to null. What does that mean? Set the foreign key in the dependent side to null. So you make this one null if you are deleting it from here. That is a separate story, how we will access that, how we will do that. But do you understand what we are doing over here? That if I delete customer ID, make it null over here. It has to go null, right? So that is what they have said. So now remember these delete rules. Restrict, don't allow delete of parent side if related node exists in the dependent side. It will be called a restrict. Cascade, automatically delete dependent side rows that correspond with the parent side row to be related. So if I delete this row, for example, the customer ID one row from here, the row of customer ID should also be deleted. That is called cascade. And set to null, set the foreign key in the dependent side to null if the deleting from the parent side. So if I am just removing, I am removing that one. So I'll just come here and I'll make it null. Because I'm removing, for example, there was a customer with ID 1 and I'm removing this, this customer ID 1. So I'll come here and I'll just remove that one as well. That's a different story, that whether how I would be able to access that one. But do you guys understand what we are doing? That these are the three rules that you have to keep in mind. These are very important rules: restrict, cascade, set to null. So remember these names, and as I said, restrict, cascade, and set to null, and just try to remember they're working as well. Okay, let's move. Okay, so look at that over here. Referential integrity constraints are drawn via arrows from dependent to the parent table. Referential consent, look at that. I cannot, this customer ID is coming from this one. So again, this is a referential integrity. In the delete, I cannot delete that one. In the other one, what was that second one? In the restrict, I cannot do that. Cascade, automatically delete dependent. So in the cascade, what I can do is that I can delete, for example, this one and just this one. And from every table, I'll just take out this case ID, customer ID, right? So in the same way, when you talk about order line, order ID is basically coming from the order, order table. So again, it will just stop working because, it is depending upon order ID. Now product. So product is also, you see that this is dependent. So product ID is dependent. If product ID is not there, of course, you won't get a product line. Make sense, everyone? Product line. Number 12, referential integrity constraints are implemented with foreign key and primary key. So we can implement the referential integrity by using this foreign key or the or the primary key for the references. So we can create primary key as well and remove the references. Transforming EER diagram into relation. This is EER is enhanced entity relationship, right? Enhanced entity relationship. So maybe it is not mentioned over here anywhere. The mapping regular entities to relations. Mapping regular entities to relations. Number one, simple attributes. ER contribute map directly through onto the relation. Number two, composite attributes use only their simple component attribute, multivariate attribute. These are the three types of attribute which we have taken from ER and we want to just implement that in our system. Entity. So if it is a regular entity, what to do? And if it is a weak entity, what to do? Customer entity type with simple attributes: customer ID, name, customer address, postal code. Now, the customer relationship might like this. The customer table. Right? The customer table. So now this is basically done that. Now, Mapping a composite attribute. Now, when there is a composite attribute, what we'll do? Customer entity type is a composite attribute. So now we have customer address and street, city, and state. So that customer address has been broken into street, city, and space. But to make it a relation, we have to do that. Remember, atomicity of the values in our like first normal form. First normal form. To make it first normal form, we'll just take away street, city, and state separately. So in other words, what you need to remember, the first normal form should never contain. What it should never contain? Can someone complete my sentence? Should never contain multi-valued attributes, right? Multi-valued attributes. So here with address details. So address has been taken tearing apart, and it basically now shows that one. So look here, mapping an entity with a multi-valued attribute. So employee ID, name, address, skill. Multi-valued becomes a separate relation for the foreign key. So again, if there is a multiple attribute, I'll take it away. Employee ID, employee name, employee address, ID, name, and address. And skills are two separate things, right? So skills are two separate things. So I'll say employee ID and plus skill. So that is a skill that the student would like to, employee would like to just show. So this is a skill set. So employee skill is basically over here. So now multi-value attribute become a separate relation for a foreign key with a foreign key, one-to-many relationship between original entity and the new relationship. So it would be one-to-many relationship because employee can have multiple skills. Employee can have multiple skills. So all those skills will be gathered in this multi-valued one. Transforming ER diagram into relation. This is very interesting and important because we have done some of the entity work in the last class as well, or here, or relationship work in the last class as well. And today we'll just look at that. So we are transforming EER, enhanced entity relationship diagrams, into relations. If there is EER and I want to convert it to relations. For that, first of all, we have to map weak entities. What are weak entities? We'll talk about that one. Those who are dependent on others. So the definition is not mentioned in this slide, like slide number 17. Slide number 17 does not contain the definition of that one, weak entities, but it would be somewhere separately. But weak entities are those which are dependent on other entities. So weak entities are those, right? Remember that one. So mapping weak entities becomes a separate relation with a foreign key taken from the superior entity. So a weak entity, if we want to map that weak entity, we'll have to have a new table. We'll have to have a separate relation, remember, with a foreign key taken from the superior entity. So when they're saying superior, it means the parent one. So the primary key is composed of partial identifier of the weak entity and primary key of identifying relation, a strong entity. We'll see the example shortly. Look at that over here. Weak entity. Department is a weak entity. Department is a weak entity. And why? Now, how to represent weak entity? Double line. Remember last class, I showed you that what is double line and what is single line we have talked about. And here it has one employee can have many dependents. One can have multiple dependents. So one employee can have dependent, maybe spouse or kids or children, whatever. So we are saying that this is weak entity. So the dependent is a weak entity. Can someone tell me why it is a weak entity? Anyone? Why would they say dependent is a weak entity? And Sampreet, you have already answered. I want others to answer. Why dependent seems to be weak entity? What comes in your mind when we say weak entities, or why dependent? And this example shows that dependent is a weak entity. Why? I've not received any answer, or maybe
Because
someone
it
is
does
saying.
not have any ID.
Um, Begin, that might be one of the it's not that reason, but anyhow, maybe yes, you are right. But there is more reason. Begin, thank you. Anyone else? Why this dependent is a weak entity? I would like someone else to answer as well. Begin, thank you to answer. Begin has answered this question, but I want others to answer as well. Now, Varun, can you try to guess why dependent is a weak entity? And Begum has done a very wonderful job. Begum says that when there is no maybe ID, that's why it is a weak entity. Wonderful. Yes, Varun, you're right. Dependent, here in this situation cannot exist on its own. Wonderful, Varun. This is the answer. So dependent cannot. You see, if someone kicks out employee, the dependent will automatically be removed. It's not like employee goes and dependent is still there. You know what I mean? So actually, Varun, you are right, and Varun has given very right answer. But Begum, your answer was also good in that sense that you have at least answered. No one, there are lots of people who would not bother to answer even. Thank you for answering. So example of mapping of weak entity. Now, how to map the weak entity in our system? So we have this strong entity employee. So we create an dependent, first name, middle name, last name, employee ID, date of birth, gender. Now this employee ID is very interesting. This employee ID is actually for that particular employee. As always said that if you are still in the job, so you will be just over there. So employee, so you see that employee ID has been added over here. And then what happens is that first name, middle name, last name, employee ID. This is composite primary key. You look at that, Begin, it's the composite primary key becomes like all these combined together. The employee ID, the last name, the first name. Why employee ID cannot be over here? Because dependent can be multiple. And they will have different first name, middle name, and last name. And combining them with employee ID will make them. So we create them, we make the relations like this. Relations resulting from weak entity. Employee ID, employee name, and then dependent has first name, middle name, last name, employee ID. Combining them will make that as primary key, and this is the foreign key over here. Which employee they belong to. Date of birth and gender, that's separate. So now look at that. Domain constraint for the foreign key should not be allow null value if dependent is a weak entity. So the domain constraint for the foreign key should not allow null value if dependent is a weak entity. So now this foreign key, you see that, Varun? This cannot be a null. Because again, if it goes null, dependent is orphaned. You know what I mean? So this employee ID, so you look at that. The domain constraint for the foreign key should not allow null value if dependent is a weak entity. If dependent is a weak entity, we cannot leave foreign key as optional. Did you guys understand that one? And I think that's what Begum was trying to say, that there is no ID, but there is no ID, but we have to combine that ID. And in the same way, we cannot leave that one. Again, first name, last name, and middle name can be same for some particular people. So that's very interesting. That's very important that we have got multiple combined together into one ID. Now transforming ER diagrams into the relations, mapping binary relations. So one-to-many primary key on one side becomes a foreign key on the many side. Remember, many-to-many create a new relation with the primary keys of the two entities as it is the primary key. As its primary key. One primary key, the mandatory side becomes a foreign key on the optional side. Can I have a thumbs up from everyone till this point of time? Because just want to know the feedback. A thumbs up from everyone. Okay, Varun, thank you. Sunil, thank you. Vishali, thank you. Okay, Samprit. Samprit, you have a question, or maybe you raised your hand by mistake?
It was a mistake. Sorry.
Okay, no problem, Sapri. Yes, Begin, thank you. I can see your thumbs up as well. So now, one-to-many primary key on one side, foreign key on the many side. Many-to-many create a new relation with the primary keys of the two entities and its primary key. One-to-one primary key of the mandatory side becomes a foreign key on the optional side. So these are the mapping. That's very interesting. So see here, mapping a one-to-many relationship. So customer ID, customer name, customer address, postal code. So again, one customer can have multiple IDs. Now, who will tell me who has looked at the recordings of last week? This one and this zero sort of, what do they mean? I would like to just know from those who had a chance to look at the recording and they have not responded at. So Ritu, can you answer that? What does this 1 and 0 means before the values? Do you remember from last lecture? Do you have anything in mind? What does this 1 and 0 means?
No, sir. No, sir, I
Okay,
didn't remember.
okay, don't remember, no problem. Okay, who else had a chance to look at the recording? Vaishali, if you can just give that. Do you remember this 1 and 0? What do they represent?
No, sir, I'm not.
Okay, that's a poor status because you need to know that because that's something that I've discussed in very much thorough detail. Anyone who knows the answer now? What does this typically 1 and 0 means? Okay. Anyone else? Order can only have one customer, but customers have multiple orders. Might be a the right answer, but it's not the exact way of telling what it's meant. So look at that. This one on this side before this -1 or these three lines. This means mandatory. 1 represents mandatory, 0 represents optional. So customer can exist without any order, but order cannot exist without at least one customer. Varun, do you make sense? Look at that. This is very important. Customer can exist without order. Like there might be a customer who has not given any order. No problem. But it's not possible that order is there and it does not have a customer. Do you guys understand who Ritu and others? I first of all, so 1 means mandatory. If and so again, one customer can have many orders, but optional. One customer may not give any order at all. On the other side, if there is an order, there has to have at least one customer. And without one customer, order cannot exist. Wonderful. Now, mapping relationships again. Now, customer ID is basically being mapped over. Again, no null values in the foreign key. This is because of the mandatory minimum cardinality. So what we'll do is that we'll just map this over here. Again, this is referring that if order is there, there has to be one customer attached to it. And if like again, this is how we map that one to many. And again, you know that one customer can have hundreds of records, hundreds of the records in the table. So we'll say that one customer can have many records, but if order is there, it has to have one customer at least. So in general terms, I've told you that a customer can live without an order, but order cannot live without the customer. It's a very basic and general statement. Now let's move forward. Here, example of mapping M into N relationship, like many to many. Now employee ID, employee name, date of birth. Completes courses. Now here comes a very interesting thing. So courses and employees, that these both are optional. What does that mean? There might be no employee taking any course, and so the course is also optional and employee is also optional. The complete relationship will need to become a separate relation. The complete will also become a separate relation if If an employee does a course, he will complete that in a particular time. If an employee completes a course. So 0 or many or 0 or many. So employee can be there, like employee if it can have optional 1 or many courses, and 1 course or courses can have 1 or many employees. Right? So let's move forward. So this is complete relationship will need to become a separate relation now. Now the many to many. Employee ID and over here, employee ID, course ID. Both of them combined together. Employee ID is a foreign key and course ID is an individual key, and combining them will make it one composite primary key. Because certificate only, not employee. Which course certificate it is? Makes sense, everyone? Which course certificate it is? That is typically they two combine together to make a a composite primary key. Okay, and then course ID is basically the foreign key, and foreign key, when foreign key comes, referential, cascade, and whatever, all these should be coming in the mind. All these should be coming in the mind. So new intersection relation. So this certificate becomes a new intersection relation where there is a foreign key, there is employee key, employee ID, course ID. Course ID is a foreign key, which is coming from the course ID, and this is combining the student and the course. Right? Makes sense, everyone? This is basically that one. Now mapping one-to-one relationship. So now if you look at that one-to-one relation, one direction is optional. So look at that, nurse ID, nurse name, date of birth. One nurse can be in the one care center, right? Because in the care, and it will be made in charge of that one. So it's one-to-one relationship. But again, a care center cannot exist without nurse. A nurse can exist without care center. Make sense, everyone? This is typically what examples of mapping binary one-to-one relation. Right? Now let's do one more slide and then we'll take a break. Example of mapping binary one-to-one relationship. Nurse ID is there, nurse in charge, and that nurse in charge will be nurse ID. After that, matching the primary key on the mandatory side. So it is basically, we'll try to map it like this, that on the one side, it should be the care center. So care center name in charge, the name is a nurse. So whenever they hire a nurse, they would just do what? They would mention that nurse ID over here. And if that is not the case, it will not allow, the system will not allow them to hire the course, hire the nurse. Make sense, everyone? So I'm just stopping here for 10 to 15 minutes break right now. We'll take a break, and after the break, when we come back, we'll have some fun stuff. Not only these slides, but we have some slides from that one, and then I might give you a little practice for today, because practice is basically important for everyone. Right, so let's take a break of, as I said, 10 to 15 minutes, 12 to 15 minutes. And this is 1:52 in my clock right now. So I'll just write it over here, 1:52. So it is 2:02, 2:07. So 2:07 p.m. we'll be back with the break. Can you guys just put a chat message of OK here? Again, just to know that who is here and who will be back. So we are reached to slide number 25. So I'll just stop sharing for a second. Wonderful, thank you. And I'll stop recording as well, because it will just make it bigger.